Hi, in the previous video, I have shared the question paper of IAPT NGPE test of 2021. Let's solve some of the questions which I was able to do and some of the questions which I was able to do post examination. So let's start. Read the first question, which is very easy, just you need to apply a simple formula. The first question is saying that the electric field E in a certain region of space varies proportional to the position vector r, as ER is equal to alpha r. The volume charge density for absolute permittivity in this region of space, and four options are given. I think you people are able to solve this. So we need to find the volume charge density, right? So I think the question is clear to you, so I'm going to solve this. See, just apply this formula. The divergence of electric field equals to rho upon epsilon naught, right? Okay, see here electric field is given as alpha r. Just put that value. Now I think you know that divergence of r is 3, so we can say 3 alpha equals to rho upon epsilon naught, which implies rho is equal to 3 epsilon naught alpha, which corresponds to option C. So yeah, option C is the correct answer. Let's see another question. Question number 3. It is saying that for a van der Waals, the spelling is wrong over here, right? It's VAN. Uh, Alright. For a van der Waals gas whose van der Waals constants are A and B, they want Boyle's temperature, uh, inversion temperature, and critical temperature from you, and the equation of state. Uh, you, I think you people have covered the chapter real gases. If you study, you will get that Boyle temperature is given by A upon RB. Inversion temperature is given by 2A divided by RB, and critical temperature is given by 8A upon 27 RB. And equation of state is actually not given by this as it's written. It is given by A plus n square A divided by V square and into V minus NB equals to N at T. Here wrong equation is given, so this is not gonna to be the answer. Okay, so this three options is correct. Let's go to the next problem. Question number 4 I have answered. Question number 4 is a little bit conceptual, but it's a very good question and a common type of question. See, the question is given that the value of iota is given. It's given I is equal to, we know that, root over minus I, and we need to find the value I to the power r, sorry, I to the power I. So let's do it. We need to find I to the power I. This is given and we need to find this. Okay, so we know that e to the power iota divided into pi upon 2 is given by cos pi plus iota of sine pi, correct? And this is equals to 0, this is equals to iota into 1, which is equals to iota, right? So we can write this iota as e to the power I into pi upon 2, which is and here is to the power, we bring this and write in this way. So it's this and this will be multiplied, and I think you know this, sorry, I square equals to minus 1, so we are getting e to the power minus pi upon 2. So let's check the options. The options are given non-zero imaginary, sum of a non-zero real and a non-zero imaginary term, and real. So this is a real value and a non-zero value. It's not imaginary, and you can break it as a sum of non-zero real and a non-zero imaginary term, right? So option A and D are correct. Okay, so let's go to the next page. See, question number 7. uh, Many of you, I think, know the number of atoms per unit area for the shapes, I mean SCC, FCC, BCC for planes. So there is a formula that for finding the number of atoms per I mean per unit area. So I can make a video on this if you want, but here I am just writing the formulas. Just try to remember them. So let's read the question. Knowing that lead Pb is FCC crystal with radius of atom r is equal to 0.12 nanometer, then estimate the number of atoms per square millimeter surface of 100 plane of lead. Okay, this is a very good question. I am just writing some formulas. You can note that in your notebook, and if you want the derivations, I can make a video on that. But for competitive exams, you can remember this. No issues in that. Okay, so remember one thing, that I'm just writing. Just see this. Okay, so it's ready. I have written over here the planes 100, 110, 111 plane, and the number of atoms in this plane. So this is for SCC, this is for BCC, this is for FCC. Okay, so see the first one for SCC, for 100 that plane, 100 plane. You shouldn't say 100, it's 100. Okay, FCC, the number of atoms in 100 is, for SCC is 1, for 110 it is 1, and for 111 it's half. So you need to find the number of atoms per unit area, and it is given by 1 upon a square, 1 upon root a square, and 1 upon root 3 a square. Okay, see how you can remember this. You can remember this easily. See one thing, here it is 110 plane and it contains one atom, right? Here you just need to write the number of atoms and area. It is a square. Okay, next thing, it is 110. If you just take root of the squares, sum of the squares, it is 1 square plus 1 square plus 0 square root, it is root 2, right? Number of atoms is 1, and it is 1 upon root 2 a square. This is not the actual derivation. I am just providing you some shortcuts to remember this. Okay, this is half, so you will not write here half. Just see one thing, it is 1 square plus 1 square plus 1 square root, you will get root 3 a square. Okay, 1 upon root 3 a square, so it is 1 1 1. Just try to remember this. You just need to remember this thing. It is 100, it is BCC, it is 1 2 half. Here is 1 1 half, it is 1, change the second one, is 2, it's half. Okay, next same thing, 1 upon a square, here it is 2, you have to put 2 over here, and it is half, don't put half, it's 1 upon root 3 a square. Okay, next. Okay, for FCC it is 2 2 2. Okay, it is, see here, 2 upon a square, 1 1 1, 2 upon root a square, and for 1 1 1 it is 4 upon root 3 a square. So you can see this, if 1 1 1 it is all 1, if it is 1 1 0 it's all 2, and for 1 1 1 3 ones it is root 3, and a square is common for all. Just if there is, this is not the actual derivation, I'm repeating it, I just providing you shortcuts so that you can remember this. Okay, so you can remember in this way, it's very easy. So let's come back to the question paper. The question is saying that lead is FCC with radius atom R is equal to 0.12 nanometer. Estimate the number of atoms per square millimeter surface of 100 plane of lead. So it is given by that 100 contains how many atoms? It is 2, right? 2 for FCC. So and we need to find the number of atoms per square millimeter. So you can see this number of atoms per unit area is given by this. Just apply the formula. I am not calculating it here. It is you need calculator to do this. First apply the formula of R equals to, for FCC it's A upon 2 root 2. Find A from here, put the value of A, square it, change the nanometer to millimeter or millimeter to nanometer, whatever you wish, and you will find the answer as C. Please pause the video to do this calculation and comment below you get C or not. Okay, let's go to the next question. The next question is saying that a laser beam of wavelength 1.5 micron is used in a Michelson interferometer to obtain the interference fringes. The fringes remained visible for a path length of 5 meter. The lower limit on coherence time and the spectral width respectively. See the options. For MCQ questions it's very important to see the options. Just see, look at the options. None of the options are equal, right? A is not first two, if you see that the first option, that is the coherence time, is given different in all the options. So just you need to do any one, coherence time and coherence or spectral width. I have just done the coherence time and I'm just going to show you that how you can find this. See, wavelength is given, right? Wavelength 5 micrometer. Micron is micrometer, okay? X 10 to the minus 6 for converting into meters. Used in a Michelson interferometer to obtain interference fringes. The fringes remained visible for a path length of 5 meter. And you need to find the coherence time. This is very easy. If you know class 12 mechanics, you can find this, but the concept is a little bit different for this. I think you know that velocity equals to displacement upon time. This is here it is given as light, so here velocity is the velocity of light and the distance is the coherence length, which is, if you don't if you haven't studied coherence, please read it. It's important concept for understanding interference and all. Coherence time, coherence length, spatial coherence, temporal coherence, these are important concepts. Try to cover them. And we need to find the coherence time. So here wavelength is mentioned. We don't need this to do the problem. We just need that path length, which is the coherence length. It is this is the coherence length, this is time. We need to find time over here. It is L upon C. If you put 5 upon 3 into 10 to the power 8, this will give you 5 upon 3, which is 1.67 into 10 to the power minus 8 second. You don't need to check the second options, okay? So yeah, I would like to stop the video over here. I will make the other solutions in the next part. Thanks for watching the video.